The fuselage of this giant consists of three huge sections: a nose, tail, and middle. It is also called the center section. All of them are manufactured here in a huge special hangar near Hamburg. To accommodate more passengers on the plane, Airbus designers decided to make it a full two-story plane and not with a hump like on Boeing's, for example. This is where the 8 in A380 comes from. This figure somewhat resembles the cross-section of an airplane fuselage. Also in the East, it is believed that the number 8 brings good luck. And the first customer of these giants here was actually Singapore Airlines. The fuselage sections are assembled on huge slipways. They're somewhat reminiscent of scaffolding. The parts of the casing are thoroughly inspected, checked, then technological hooks are screwed onto them, which are then used so a crane can lift the parts. Afterwards, individual segments are assembled on the slipway to form a finished part of the fuselage. It all looks like a huge 3D puzzle. In just one day, the body of the future section appears from a dozen pieces. There are 6 assembly slipways in this hangar. The section simply transfers from one to another, gradually drowning more and more in wires, cables, lines, hoses, pipes, tubes, air supply systems, and internal lining. Basically, what you have here is a giant conveyor belt where a section spends several days at each stage. The aircraft body consists of only 75% aluminum. The remaining 25% are special composite materials. For example, this part is the plane's tail, made of especially durable fiberglass. Based on its characteristics, this material is pretty much the same as aluminum, but significantly lighter. Theoretically, it would be possible to make an entire plane out of this, but it would simply be very expensive. Besides, according to developers, the trickiest part in creating the aircraft is the issue of reducing its weight. This monster is so huge that its own projected weight could have prevented it from flying. This problem was solved not only thanks to fiberglass, but also augmented aluminum alloy. As a result, only 40% of the center section consists of volatile metals, while the rest is made up of composites. After the body of the sections is ready, it is carefully wrapped from the inside in a coat, I guess. It's a special heat-insulating material due to its ability to retain heat. A thin layer of such fiber replaces a 10-centimeter layer of glass wool. But that's not even the main thing. In the event of a fire, God forbid, of course, this material is capable of holding temperatures of several thousand degrees for 90 seconds. Every square centimeter of this aircraft has been planned down to the tiniest detail. The thermal insulation material, for example, arrives in segmented pieces based on special templates. Even if the worker wanted to, he wouldn't be able to attach the wrong segment to the casing. It simply wouldn't slot in with the others. So this shirt will fit our monster like a glove. We all know, of course, that an airplane is a tough nut to crack, but I'm afraid we can't even imagine how complicated it is. For instance, when we enter the passenger deck, we can't even begin to presume what's under our feet. Now you have a unique opportunity to see this. Hundreds of wires, 1,000 contacts, but you know what? This is just for starters. You should see what's happening under the ceiling. One A380 has 530 kilometers of wires. In the cockpit alone, there are about 10,000 of them and about 40,000 of their various connections. They are everywhere. They weave through the entire plane from nose to tail. Every second, huge amounts of information and hundreds of volts must be transmitted through them. These are like the nerve endings of our monster. By the way, main connection lines are duplicated 3 times. If a short circuit occurs in the main line, the backup will cover it. Should the second fail, the third will take its place. And that means that mainline wires have to be fitted 4 times over. All this in conditions of extremely limited space and severe time pressure. To get to any given connection, workers sometimes have to use rather exotic tools. A dentist mirror, for example. But to be fair, this version's a little bigger. Fitting the electrics is the most difficult stage of equipping this section, which is why it spends the most time on this slipway. The huge structure is then transported further. At this stage, air supply and air conditioning systems are installed inside the section. By the way, none of the air ducts are metal, aluminum, or even tin. They're made of fiberglass. And again, because it is lighter. In fact, all the air in the A380, and that's 1,500 cubic meters, is completely exchanged every 3 minutes. As a result, absolutely everything is installed in the sections except the inner lining. After all systems have been checked tenfold, along with wires, pipe connections have been tested, only after this are the ends of the huge sections covered with fabric and the huge components of the aircraft rolled out of the hangar onto the pier. In total, 3 aircraft are assembled in the assembly shop at the same time. In turn, the 3 main assembly slipways are set up here. When the fuselage parts take their place, the slipway, with a total weight of 1,200 tons, seems to envelop the future monster from all sides. The 3 sections of the giant aircraft's fuselage, plus 2 more wings, are assembled on this slipway, like some kind of children's construction set. Added to all that, this monumental work takes only 5 days. Here, by the way, is the place where the 2 parts join. Note that one section slightly falls over the other, so they end up overlapping. Here they are fixed with clamps like this. The sections are drilled and fashioned with rivets like this, and there are 3,000 of them here. So, oddly enough, the place where the 2 parts of the fuselage join is one of the strongest and most durable places on this plane. Still, riveting different sections to each other isn't exactly rocket science. That being said, you do have to tinker with connecting and labeling all the electrical and computer systems. It is this incredibly painstaking and vital job that takes up most of the time.
We have several hundred people working here. With such a workforce, of course, it is very difficult to control everything. Tens of thousands of rivets need to be fitted and thousands of wires soldered. But we've established a setup in which everyone does their own part of the job, and then an inspector comes and checks it all multiple times.
How many times?
How long does a plane spend here?
4, maybe 5 days.
5 days?
Yes.
That's not long. I'd even say it's really fast.
Oh, yeah.
And in these 5 days, you connect all the sections together, install, and even connect all the internal systems, yeah?
Yes, that's right.
Incredible.
This is a very stressful job. The longest we've held a plane here was 7 days. But that only happened once.
One of the trickiest operations is joining the wing consoles to the fuselage. They're moved to the desired position by crane beams, and then precise laser corrections are performed. Around 4,000 high-strength bolts are used to connect one wing to the fuselage. And that being said, fastening the sections is no easier. So that the worker, God forbid, does not mix up and suddenly drills holes in the wrong place, there are these templates here. They're simply applied to a certain part of the fuselage, secured, and then with a special gun like this one here, holes are made through the holes in the template, into which rivets are then inserted. It turns out that there are tens of thousands of rivets in one place, and each one has its own place. What's more, there are also several thousand such templates on the assembly slip, and each one suits only a certain place on the aircraft body. The final silhouette of our monster has already taken form on the main slipway. Now it is being retrofitted with various units and mechanisms. This device will control the flaps of the A380, raising and lowering them, And with their help, the plane itself either gains altitude or descends. On conventional aircraft, this mechanism is much smaller. However, this is not surprising. The area of the flaps alone is the same as the entire area of a wing on an AN-24. Several teams are working in parallel on the assembly slipway. One is responsible for the tail, the other for the right wing, the third for the left, and so on. It's important that everyone keeps in time with their schedule. After all, just one sluggish group of 4 or 5 people could delay the delivery of the entire liner, and this spells colossal penalties. One of the most critical areas is the installation of the landing gear, which, by the way, contains Russian titanium. This is generally the only element of this huge aircraft where products from our industry are at least somehow used. But to be fair, this can be deemed as a very crucial unit element. It takes on a huge load when landing. And of course, titanium is one of the strongest metals on Earth, the only one capable of handling the task, provided that the wheels don't fail. A set of tires for the A380 consists of 22 huge wheels with a diameter of 1.5 meters each. On top of that, they're so powerful and the pressure inside is so strong that you can't even believe that the sound is rubber, so it completely feels like wood or, I don't know, plastic. And yet the load on these wheels is so great that the footwear for our monster has to be changed periodically. And that means about once a year. The planes that are on the slipways have yet to be painted. After assembly is complete, in this slightly unpresentable form, they fly on their own from France to Germany, where they'll be given the final polish. The only detail that's already shimmering with all the airline colors is the tail. In fact, there's an online camera installed under the ceiling in the assembly shop. The customer of the aircraft can see the feed from it, and from the tail, he can determine which of the 3 aircraft is his and what state of readiness it's in. Once the aircraft is fully assembled, it needs to be fully checked to make sure everything is correct. Interestingly, this process takes the same amount of time as the assembly. It happens in this hangar, plus they also install the engines. As a result, about 3, sometimes 3.5 fully finished aircraft are rolled out from here per month. I mean on average, of course. That means only 35 to 40 monsters are assembled here per year, and the concern's order portfolio includes hundreds of aircraft.
This is where we carry out our testing. Extensive checks are carried out over several weeks to ensure that the electrical and hydraulic systems, as well as moving aerodynamic surfaces, such as rudders and wing mechanization elements, are fully operational.
A thorough and lengthy check is performed on all engine systems. A big plane needs a lot of thrust. And although the A380 can fly confidently even with one failed turbine, it's better not to cause a heart attack. The A380 has 4 hearts, giant engines each packing 70,000 horsepower. And each of them burns hundreds of liters of aviation kerosene in just 1 second. Interestingly, these turbines for the A380 can be made by 2 completely different firms competing with each other. The customer himself chooses which engine he needs, and any of them will fit here like a glove. After all checks are complete, the aircraft moves out of the workshop and onto the airfield to perform what's known as a pressurized cabin test. It's akin to pressure testing batteries in our homes, which utility workers carry out before the cold season sets in. During this operation, excess pressure is created in the cabin, which significantly exceeds the permissible value for operation, to identify the possible presence of leaks. If everything is fine, pilots are brought on board for the final test. Their task is to make the first test flight. In other words, to get this monster up on its wings. The A380 cockpit is almost the same as any other Airbus aircraft. The company specifically makes them the same so that pilots can more easily transfer their flying knowledge from one type of aircraft to another. But they made an exception for this monster. Overall, the set of instruments is the same, but the displays are almost 1.5 times larger, as a big plane needs big monitors. Romantic French pilots claim the first flight for any A380 is like a first kiss. Unique, each one has their own, and it's always beautiful. After all, only from this moment on can this huge and complex airline be rightfully called an airplane.